Okay, for this question, right, the length of the beam is not specified. So let's see each segment of the beam as 1 unit of length. Okay, we can see that we have a 5 Newton acting downwards, 4 Newton acting downwards, and a 4 Newton acting downwards. So this 5 Newton and this 4 Newton, they are going to turn the beam anti-clockwise. So these are anti-clockwise moment, and this 4 Newton is going to turn the beam clockwise. So it's going to constitute to a clockwise moment. And we see that the anti-clockwise moment is larger than the clockwise moment, so we need to position another 2 Newton somewhere here such that it can balance the beam. So how far is it away? Let's do some calculations. Okay, so using the principle of moment, total clockwise moment equal to total anti-clockwise moment when a beam is balanced. We have 5 Newton multiplied by 1, 2, 3, 4, 4 unit of length, plus 4 Newton multiplied by 2 units of length is equal to 2 Newton multiplied by an unknown distance to the pivot, let it be x, and we have 4 Newton multiplied by 1, 2, 3, 4, 5 unit of length. So we have 20 plus 8 is equal to 2x plus 20. So 28 is equal to 2x plus 20. 2x is equal to 28 minus 20 equal to 8. X is equal to 4 unit of the length. Okay, so now let's count 1 unit from the pivot, 2, 3, 4. So our 2 Newton should be down here at position D. Alright, to investigate the stability of the 4 empty containers, right, we look at 2 factors. The first one is the base area. The larger the base area, the more stable it is. And the second one is the center of gravity. The lower the center of gravity, the more stable the container is. Okay, so for base area, we find that B and C, they have a relatively small base area compared to A and D, so we can eliminate them. And the next thing, let's look at the position of the center of gravity. Okay, just need to draw a horizontal line that cuts the beaker into equal half, top and bottom. And we draw a vertical line that cuts the beaker into 2 equal half again, but this one is left and right. And the intersection point will be the position of the center of gravity. Okay, then we look at container A is broader at the bottom and narrower at the top. So the horizontal line should be closer to the bottom, and the vertical line should be in the middle. So in this case, you can see that the center of gravity is below the center point of the container. So in this case, since the center of gravity is lower for A will be more stable. Okay, in this question, we have a fence, and on this side, because the wind is blowing, the pressure is 105 kilopascal. And on the other side, where there is no wind blowing, the pressure is 103 kilopascal. Okay, so from this you can see that the wind brings about a pressure of 105 minus 102 Pascal, which is 2 kilopascal of pressure. So this pressure is caused by the wind. Okay, to find the resultant force of the pressure, we can use the formula. Pressure caused by the wind is equal to the force exerted by the wind on the fence divided by the area. So this will be 2000, because it's 2 kilopascal, is equal to the force, resultant force divided by the area, which is 4 meter squared. So the force in this case will be 2000 times 4, 8000 Newton. Answer B. For this device, on one end is connected to the gas supply with pressure P. Okay, so let this be P. And on the other end, it is experiencing a pressure due to the mercury column down here. Okay, let's call it the pressure X. And on top of it, the atmospheric pressure is acting on it. So we can say that the pressure of the gas P is equal to the pressure of the column of mercury here, which is indicated by pressure subscript X, plus the atmospheric pressure. And the pressure of the column is due to X meter of the mercury, and the atmospheric pressure is H meter of mercury. So we can say that the pressure of the gas is equivalent to the mercury column of X plus H meter. Okay, so the answer in this case, it should be A. Okay, we have a force F that is pulling the trolley up a ramp. Okay, so since there is no air resistance or friction, there will be no work done against air resistance and friction. So all the work done by the force here, it should go into the kinetic energy and the potential energy of the trolley. Hence the answer should be B.